We have to change it there, yeah.
Let me just see if I can just comment on that. Yeah, actually.
Yeah, so
just
yeah, so it see both of you. Sorry.
That's good.
Yeah, so
Well, this can also move slightly.
sorry.
I don't want to be in the way of the screen. Good.
Because we need to have this screen as well. Yeah, because and if yeah. Yes, it should be fine. I think that.
You know, so it's for the gentleman's presentation. So we wanted to show it on the screen when he plugs in. It's on our PC at the moment. He just has to change over to HDMI, so which will bring up his presentation on the screen.
Can we do it now?
Yes, if you want to.
Yeah, please.
So you just press that and you plug the gentleman.
Yes. Then
Yeah.
Thank you very much.
yes, my. By the way, it's not coming.
Sorry. Yeah, I think it's.
It's not coming. Now, can you press F? Yeah, no. Yes. Okay. It's good. It's good. Okay, so let's start. Okay.
Okay, good morning. So welcome to the University of Leicester. So I'm Professor Lu Liu. I'm head of school for computing and mathematical sciences at the University of Leicester. So on behalf of my universities, I would like to warmly welcome you to visit our university to attend the IEEE ACM UCC and BDCAT 2021. So there's a lot of restrictions in organizing conference during the pandemic. So for example, actually here in College Court, actually this was serving very nice food for the all audience. But due to the COVID restrictions, we can only serving the Sunday lunch for today. And also university also expect everyone in the campus to wear the face coverings like in the corridor and also in any communal areas. So I'm very sorry for any inconvenience this may cause. So we are the local host. If you've got any questions with any problems during your stay at Leicester, please do not hesitate to contact us. So we are here to support you. I hope you will enjoy the conference and also enjoy your stay at Leicester. So now hand over to Professor David to give you more information about the conference.
Thanks very much, Lou. So it falls to me to welcome all of you here in person in Leicester in our nice socially distanced room, everyone on Zoom, everyone on the YouTube live cast, any future viewers of the recording, and to the joint International Conference on Utility and Cloud Computing and BDCAT, Big Data Computing Applications and Technologies. I'm one of the general chairs of BDCAT, but I'm opening the conference on behalf of all the general chairs. So on behalf of Zinkri Zhao for BDCAT, my colleague Eva Zillman at ISI in the States, UCC, along with the group. So thank you very much for all being here. Thank you to everyone who's organised this event. And we just heard about some of the complexities. This is a very difficult moment in history to organise conferences. It's a bit like organising two conferences at once, twice, because there's the online experience and there's the in-person as well. So thank you very much to everyone who's brought this together. I'm based in the University of Oxford and at the Alan Turing Institute. And I've been working in e-science, e-infrastructure, e-research for very many years. One thing's for sure, these topics are never more important than they are today. And I was really excited to look at the program and the Keynote program. We had some fantastic talks, and thanks to everyone who's written the papers, co-authored the papers, reviewed the papers, to the program chairs. So for UCC, that's Joseph Spiller, Alvaro Brandick, and Rizos Skaliaru. And for BDCAT, it's Olga Daskova, Lydia Chen, and Robert Burke, who I think I saw online just now. So thanks to everyone for bringing this together. We probably have some statistics about the program committee process, but I don't have those at hand. We might report those later. I want to give special thanks to the organisers this year, but also a shout out for the organisers for next year, when it's going to be held at Washington State and Texas Tech, hosting next year's event. Long history to both of these events. You can tell by the numbers: 8th BDCAT and 14th UCC. So welcome everyone. You may hear some more things about history from the other presenters and future plans. But with that, I'd like to hand over to, I think, Omar, are you going to mention the panel on Wednesday? Thanks very much.
That's great. Thank you. Thank you very much. So I just wanted to, so I was general chair last year, so we had it all online. So we had to pivot to online about mid-year last year. So we had to, it was a very difficult and interesting decision. So I think, as David mentioned, so I come from Cardiff, and I guess we have a panel on Wednesday at 4:30 p.m. UK time. It's on computing in the era of climate change. And we have Alan Still, who's going to be the general chair next year. So we'd love to get you guys online and ask your questions. We have a bunch of panelists from industry and also academia. So there's a web page for the panel. So please join and ask your questions. Thank you.
Thank you, Omar. Okay, good morning. Good morning, everyone. I'm Professor Nick Antonopoulos, Deputy Vice Chancellor for Research and Innovation at Edinburgh Napier University. And it's my pleasure to be really assisting all my colleagues across many universities in opening this great conference. Just to say a couple of words about the conference. It has been one of the premier conferences in cloud computing, with cloud computing in its kind of widest interpretations of talking about systems, talking about infrastructure, services, and of course contextualized applications that make a difference to real life. I've been affiliated with the conference for a number of years, was the general chair in 2014, 2016, and 2020. So an absolute pleasure to be able to see a number of you here today, and of course a big welcome to our online audience and colleagues. I'm pretty sure, as David said, that you will find the content of the conference over the next few days extremely useful. Can I say it's a great opportunity for a conference, mixed conference of UCC and BDCAT to be making a true and genuine difference in the grand challenges going forward. And of course, the whole world these days are absolutely focusing on well-being and environmental sustainability. So really keen to be listening to presentations and work that can have applications and real impact to real lives and the society in general. So thank you very much. I hope you will enjoy the conference. And let me now take, yes?
Just a minute, because Joseph is coming online.
Is he?
The program chair for UCC. He wants to say something.
Okay.
Let me share his slides. I should probably,
Just connect your laptop.
I need to connect the laptop. Yes, please.
Right. Connecting from here.
So Joseph, just a minute, please.
Hi, Joseph.
Can we
just take this out? Can you try this?
so that we close everything else?
Yeah, let's go to the Zoom session.
Okay.
I might need to.
Okay, maybe you could start with the computer.
Yeah, just one sec. If we just go to the Zoom session here.
Okay, yes.
Okay. Go ahead, Joseph.
Joseph, you need to present your slides, please.
I'm unfortunately unable to do so. The both disabled participant screen sharing.
Okay, try now, Joseph.
All right, looks better now. So let me just show you a few words about UCC. You should see my presentation now, right?
Yeah, can we get the volume on this? The volume on the PC? Is it possible to increase the? Thank you. Yeah.
Is it better now?
Yeah, try it.
Okay. All right. So a few words from the technical program committee chairs, Ivana, Resource, and myself. We're very pleased to have had such a great influx of submissions from authors around the world, contributing to the 14th ACM UCC. We would like to look ahead a little bit, because we can now look past the last conference iterations. Couple of years have passed. I myself got involved 10 years ago, exactly 10 years ago with this conference, and of course cloud computing has evolved quite a bit, so we would like to look a bit in the future. So first, some statistics. We had 62 submissions. Those were reviewed by 74 PC members and 31 external reviewers. Each paper received 4 reviews. That led to 270 reviews in total. So quite a thorough review, quite a heated debate sometimes about which paper merited the entry. We can see country statistics in the chart, and overall we finally admitted 21 papers into the technical program. 1 session will run today, it's the physical session, and 6 sessions will run tomorrow until Thursday. We will of course determine the best paper from those presentations, and I can also say that to the Journal of Cloud Computing. We are very delighted that this year we have 2 papers with a special badge from ACM, from the Artifact Evaluation Committee, that made artifacts available, and so this will be specifically highlighted in the proceedings. So if we look back, of course, we always had the interesting topics around cloud computing in this conference, including the predecessors. So we can say from around 2006 to around 2016, we've had around 10 years of very foundational research into cloud computing, and there was kind of a crisis. What would cloud computing lead to? What would be the next steps? And we can say that in the past 5 years, this has really been refined into many different ways. We see a lot of topics that are now of high interest to many researchers. We see a lot of publications also in this conference on serverless computing, on all the different variants of continuum computing, all the different continuums that exist, but also emerging topics such as quantum and disruptive computing, all computing paradigms that have emerged from cloud computing are not departing from the model, but are refining it so that we can address the next challenges that we have in society, in industry. So with that, I would like to show you the outlook on the program. We have 2 excellent keynotes today, as well as the first technical session. We also have a keynote tomorrow and one on Wednesday, and we have more sessions also on those days. I think it's going to be an excellent program. Of course, UCC, in conjunction with BDCAT, with the workshops and the doctoral consortium, so you have a lot to choose from. I'm happy to see you in the sessions. Thank you very much.
So Robert is there, he wants to present BDCAT.
Yeah, we have the problem with the sound here.
Okay, we will fix that.
Yeah. So maybe we should just fix the sound. Okay. Okay, so I think we just have to switch the sound a little bit, guys.
Hello?
Hi, Robert, just trying to fix the sound.
Okay.
Yes, better.
Okay, so is it
That's
better
better.
now? Okay. So can we get the next speaker? Who's the next speaker?
No, so Robert is going to share his slides, his program here for BDCAT.
Okay,
So,
is it there?
Yeah.
Robert, okay, Robert, do you want to, let me just give you access. I think we just
Yes.
want to.
So Robert, can you please share your slide?
Yes, you need to activate share,
it's
screen
done now.
sharing.
Go ahead.
Yeah, so yeah, you could do that now.
Right now.
Okay. Yes, now it seems to work. Perfect. Good. 2 seconds. Okay. Do you see the slide?
Yes.
Yep.
Okay, so thank you also from the BDCAT side. It was an honor to be PC chair, co-chair together with Lydia for this conference, which I think is a great conference. We had received a total of 35 submissions, covering a whopping 107 authors from across the world. I just wanted to show a bit of the statistics. Naturally, we have, as kind of very common, United States and China leading, but we had also a very quite high number of submissions from Australia, India, and also UK. And all the way down to Italy and Slovenia. We were able to put together a PC committee of 41 members, which actually were quite very hardworking, and they're providing 127 reviews with an average of 3.6 reviews for each submission. And based on these reviews, we have selected 11 papers to be presented as full in the next over the next 3 days, and 4 papers to be presented as short. And we really want to thank both the PC members for their really hard work in providing all these high quality reviews, and also to the authors for submitting their papers, and which are at the heart of any conference. Yeah, so thank you very much.
Thanks very much, Robert. So I'm going to hand over to Nick to introduce our first keynote. Welcome again, everyone, to the conferences. Thanks to Robert and Joseph for giving us the stats on the program committee process. Thanks very much.
Thank you very much, David. So I'm really delighted to be welcoming Dr. Gilbert Owusu from British Telecom, who will be our first keynote speaker, and he will be talking about the Digital Twins initiative for services and operations, and really how far we have come in terms of that journey. Just a few words about Gilbert. So Gilbert is British Telecom's Data and AI Director for Corporate Units and Networks, a very strong track record in applying AI and operational modeling technologies, which have led to significant customer service improvements and OpEx reduction in BT's operation. Gilbert's work on applying AI technologies for transforming service operations have been published widely in journals, conferences, and book chapters. He is the co-editor of 2 books on service production management, a visiting professor at the University of Essex, a member of the UK Operational Research Society's General Council, and an executive member of the British Computer Society's specialist group on AI. So without any further delay, Gilbert, if you'd like to join us. The talk, I think, will last about 45 minutes. So we'll be having ample time for questions. And can I just ask our colleagues who are joining us online, do feel free to use the Zoom chat room to post your questions, and we will take them at the end of the talk. Thank you very much. Over to you.
Thanks a lot, Nick. So what I plan to do is catalog or some applications that we've developed in BT. We've been on the journey to build digital twins of our network and operations for the past 4 years or so. So most of what I'll be talking about will be our experiences to date in there. So just by way of context, I mean, digital twins aren't new. I think very much part of the balance these days within IT. But just to bring us all up onto the same page, there are advanced simulations. Now, there are many definitions, but I tend to prefer this advanced simulations that are designed to deliver specific business outcomes. And for us, that is the objective: deliver specific business outcomes. They are representations of actual or physical assets, but in our case, these could be humans, and some of the examples that I'll be sharing in our operations reflects that as well. So when we look at digital twins, I mean, of course, what is beginning to emerge is that there's a need to build a so they are federated models of digital twin, and this is being championed by the National Digital Twin Initiative within the UK. I'll touch on some of the work that we are doing with them on that front. And also, it is widely acknowledged that digital twins are key enablers for Industry 4.0 and cyber physical systems. Quite a lot, that word has become quite prominent, especially in the funding bodies in the UK. I mentioned digital twins are not new. So way back in 1970, NASA actually used a pair model of the Apollo 13 to test out strategies before issuing instructions to the scientists up in space. So when faults occurred, they used the model to make sure that those strategies work before then. This has been ongoing for a number of years. We do know that scientists and engineers build models before actually implementing them. But what has been missing is the link between the physical model and the physical assets, let me put it that way, and the model that has been built. They tend to be separate. And this has led to a lot of costs in maintenance. So a recent report by Accenture highlighted that about 60% of any organization's IT budget across the globe, and this equates to around $50 billion, is devoted to maintenance of IT systems. Yeah, and from my point of view and what we share internally in BT with some of our colleagues, this tends to be related to the lack of, or the link, the missing link between what is designed and what is actually implemented. And digital twins promise us to help address some of these challenges. So just to call out some of the benefits, I think you are very familiar with this. From the National Digital Twin Initiative within the UK, they flagged 3 key benefits of digital twins. One is for strategic planning. The second is around maintenance of assets. And then the third is about assurance. But there are others. So around strategic planning, of course, you would engage in simulations and experiments, quite a safe way to de-risk your operations, especially if you're working in a very capital-intensive project. We want to make sure that we get it right before deploying them. In our case, probably rolling out fiber or whatever it is. Sharing data, again, the promise of digital twins is to enable us to have the way to share data across sectors or even within the organization, because to have meaningful digital twins requires us to have data across an organization. And in our case, in some instances, data from other utilities. So when we are digging to lay out fiber, for example, we need to know who else is working in that space. Managing operations in real time. I alluded to that earlier on around maintenance of assets and even software. Having digital twins will help us minimize the cost of running operations in real time. Ensuring that we can have reliable designs, getting it right first time as well. Okay, a key thing for operations. And then in terms of visibility around security as well. Being able to demonstrate that whatever we are building is secure before deploying, then digital twins enables us to do that. And then finally, of course, collaboration. And there is a lot of focus or shift towards cross-disciplinary initiatives. I think digital twin provides us to do that, either by design, when we are designing assets or operations or whatever it is. It's not just the engineers and the scientists involved. We can bring behavioral scientists and others into the mix as well. And I mentioned the concept isn't new, but what we are seeing, and I think the conference touches on some of these key trends, IoT has enabled us to do this quite a lot, being able to deploy sensors to capture images, the cloud, again, in our case, being able to host or actually process and store whatever data that we are capturing from the IoT devices. AI, key one. I mean, I mentioned addressing specific business outcomes. That for us, it's using AI to do that. Mixed reality capabilities, again, the way to visualize whatever it is that we are building. Digital twins helps us to do that. And of course, blockchain in terms of securing the transactions and data. So the National Digital Twin came up with this maturity framework to assess where we are at when it comes to developing and deploying digital twins. And I think most organizations are around the level. Okay, so we do have capabilities that have been static models. They are digital twins in their own right. Getting to 3, where you have real-time data feeds, that can be very expensive, especially if you are not starting from greenfield. So with legacy systems and so on and so forth, retrofitting them with IoT sensors, it is an expensive exercise. Okay? And I would suggest that probably there are research opportunities there to see how these can be done. Then, of course, one those two-way integration. So that link between the physical model and the digital model. And of course, we want to get to a stage where there will be autonomous behavior. Okay, so the operations look after themselves, and that is where we all want to get at. Most of all, I'll be sharing will be around this area. That's where we are at as an organization in BT, but of course, looking and working towards this level. So we've taken an engineering approach towards this. For us, data is fundamental. Without having the right data in place, we are not in a position to have digital twins built. And the challenge is, if you're not starting from greenfield, you have a brownfield IT estate or whatever, sometimes your inventory records may not be up to date, okay, because of the way they were designed. And most IT systems are designed for specific purposes and evolve over time to account for other new use cases. So being able to capture data that reflect have isn't, it's not a feat that we could easily address. And we spend quite a lot of our efforts using AI techniques to help us do that, asset reconciliation, okay, improving the quality of the data that we have, and so on and so forth. Then we have another layer where it's more around modeling. So once we've captured the data, how do we go about modeling our operations and services, and being able to interact with those models? So we do here use a lot of mixed reality technologies, okay, in the, whether it's the augmented reality, HoloLens, and so on and so forth. Then the use cases come up, and I'll go through those a lot in a bit. Of course, as I mentioned, no digital twin can work by itself. So we have linked in with the National Digital Twin Initiative to see how we can work with other organizations along those lines. What we see here is that from an operational point of view, business cases will have to be anchored at this level. You wouldn't be giving money just to go clean data. That doesn't happen. Okay, it has to demonstrate the value that a business is going to get out of that, and then you can work your way down. So in some sense, you may not get funding to build a digital twin. That doesn't happen. You get funding to build use cases. And as part of those use cases, we're able to take the opportunity to build the digital twin accordingly. So I mentioned data. Good data, as we all know, are key to getting the most out of AI models. I touched on the incomplete or incorrect nature of data, and we have seen that, okay, in some of the models that we have built. And one of the challenges, and I believe we are all IT people in this room or on the call, handling data legacy or data from legacy systems, it's always a challenge, okay, because of different formats, different sources, the way they handle them. And these are some of the engineering challenges that we need to fix. And of course, I touched on this earlier on, visibility of data from other organizations. Sometimes you need that to be able to augment the data that we have internally. So we've been looking at that. And what I'll be going through now will be the way we have gone about engineering some of these applications. I mentioned that for us, it's very much the use cases. So I'll go through some use cases, okay? And then of course, touch on what it's remaining or where we want to get to. So AI, it's a key enabler for us to design and develop those use cases. We have a framework to help us to do that. Of course, underpinning that will be the data, the tools, the infrastructure. So we have invested quite a lot into cloud platforms, and we'll touch on that in a bit later. Standards, ethics, think that it's very much talked about these days. But again, how do you go about making sure that when we procure AI systems, from vendors, they actually do what it says on the tin. Whenever you purchase a white goods, there tends to be a sticker, if it's a fridge or whatever it is, telling you the energy levels. You know exactly what you are getting. We don't have that for AI systems at the moment. So if a company X comes and says that I'm selling you a speech recognition system, there isn't a way to certify that it does what it claims it does. Okay, so that is an area of interest for us. And then internally as well, quite a huge undertaking to upskill our colleagues around AI and making sure that we are all aware. And then, of course, we work with a number of universities to help us leverage the best out of the AI research. So just before I go into the use cases, what most people don't know is that BT is the #1 company when it comes to filing AI patents in the UK. Okay. It isn't talked about. I just wanted to flag this. We're about some of the big IT companies as we do know that. And this is a report that was produced by the IPO a couple of years ago. We do use the whole spectrum of AI. Okay, most of the focus these days tends to be around machine learning, but AI is bigger than machine learning, as we all know. And some of the success stories we've had center around the optimization bit. And of course, you have symbolic processing as well. So these are the areas that we use AI for to help us optimize our operations, service and operations. So we are a resource-rich company. So we are the second largest fleet operator in the UK, second to Royal Mail. We have just under 30,000 vehicles in our fleet. And I just also, okay, so 10,000 vehicles in our fleet. So our challenge is to make sure that the resources we have around 30,000 vehicles as well, how do we go about optimizing the way we utilize them on any given thing? We do have systems that we use for recognition. Okay, so nuisance calls. That's one key use case of AI that we've implemented, blocking nuisance calls. Looking at diagnostics within our network so that when customers call, we can proactively, or before they call, proactively spot issues and resolve them. And then, of course, customer journeys, predicting, looking at process mining and predicting next best action in there. Other use cases that we have, I mentioned the field engineering space, the way we roll out fiber, it's also key for us. It's an optimization problem because there are many constraints that we need to take into account. Cybersecurity, again, we offer that, making sure that we can detect anomalies, behavior in our network. So a lot of AI, it's used in there. And then energy, we consume about just less than 1% of the UK's electricity. So a lot of effort goes into how we can optimize our electricity usage there, how we can prepare data attached on that. And more recently, software. So how can we use AI to help us improve the software engineering process? So a lot of work goes in there. And then immersive training. I mentioned again how we could make sure that AI plays a part in recommending relevant training programs for our engineers. So I'll now go into what we've done in our workforce of field engineering teams. This for us, when we started this way back in the late 90s. We didn't think of it as, it was the digital twin concept wasn't there. But what has become apparent is that the infrastructure that we built for managing our 30,000 or so field engineers is a digital model. So these are humans, okay? It is a digital model. It's highly instrumented with a view that we can optimize the way we utilize them. So I mentioned 30,000 or so field engineers. They are multi-skilled. So a typical engineer could have, let's say, between 6 to 9 different skills. They have preferences in terms of where they work. They are mobile. They have different shift patterns. So we have in excess of about 4,000 also shift patterns within the business. Okay. And we do know to the minute, second, how we utilize these engineers. And for us, that has been one of the blueprints in terms of the way we instrument operations. So I'll walk you through some of the journeys, the journey that we've been on in that space, what we've actually done, and how we are looking at scaling that up to other operations. So objective, I mentioned the business outcome. Our objective is to make sure that we deliver business outcomes. And for us, twofold: optimize the way we utilize our engineers. And secondly, deliver better service outcomes. Okay. To be able to do that, we must have full visibility of demand coming into the business. There are two types: what we capture from customers. So this is data coming in. And then what we don't know, we forecast using prediction models. Weather plays a key part in our demand. So weather impacts repair. So when it rains, there may be faults in the network. So we generate a baseline demand and then superimpose the weather data or external influences on that to give us a full visibility of demand coming into the organization. Once we've done that, we then look at how we optimize the use of these engineers. So this requires us to know who the engineers are. So again, it's around fine-grained data about the engineers, what sort of skills they have, when they are available to work, where they can work, and any constraints that might apply to the way they go about delivering their work. Again, this is a digital model of our operations of an engineer. We have that, we match the supply to the demand, and then address any gaps that might arise from that process. Then, of course, we go about allocating work to them. Some of the capabilities that we have as well is to be able to design where we place them optimally. And then providing service insights, checking to see that whatever we've done, it's actually producing the right outcomes. So there's a feedback, closing closed loop system in there. So just to illustrate what we do, our engineers are assigned to patches. So these are geographical areas where they pick up work. So we have, again, clear visibility of where these boundaries are. We assigned the squares there denote engineers. We assign an engineer to one of these patches. So that's their home patch. Over time, they become very productive in that area. But when you and I look, on the screen, we'll probably prefer to give this particular engineer maybe work in a neighboring area. Again, due to constraints of systems that have been built over time, it doesn't happen. And of course, they are here, they are assigned to these for managerial purposes. they need to be performance managed their patches and so on and so forth. But we want to maximize productivity. So what we did a few years ago, working with one of our partners, is to relax these hard constraints, maximize, and we use fuzzy logic for that, maximize the way we utilize these engineers, and then recreate these boundaries because you need them for managerial purposes. And on the shift patterns, similarly, I mean, you develop shift patterns that could go out of date quickly. Okay, so what we do there, just to illustrate, particular shift pattern was created at a point in time, suggesting that we should have between 19 and 38 people on any given Saturday. Again, if you have more work than people, you're going to feel SLA. So what we have done is to create a model looking at demand, full visibility of demand, and then the business objectives in terms of SLAs, optimizing that with a recommendation that we should have either 27 or 28 on any given day. Okay. And the reason we're able to do this, again, goes back to instrumenting that operation, making sure that we are fine grained data about the engineers and the processes that we have. We don't always start from greenfield. Okay. Most of the time, we are building on stuff, systems that have been deployed. Put this up just to illustrate that. And again, to illustrate the gap between tends to be designed and what actually gets implemented. So at a point in time, process designers come up with a diagram, a process diagram, as you see on the screen. Beautiful swim lanes, everything. It's perfect. But this is what actually happens in practice. People find workarounds and so on and so forth. I use this to illustrate why it is difficult to implement digital twins, okay? Because if you can design this, but if this is what actually happens, how do you, let me say, reverse engineer or whatever it is, okay, to a state where you will be in a position to capture the right data to build your digital twin on. Okay. So what we have done is to build a process mining tool within the business, and there are a few out there that enables us to mine the processes and then spot basically issues within the process. Okay. And in this case, you can see that there's a lot of repeats, maybe workarounds, and so on and so forth. You need to clean the data, address all these issues before you can build your digital twin or the digital twin of your operations. So once we have done that, one of the things that we do is every so often, whenever there is a product launch or we need to change the shift patterns of the operational teams and so on and so forth, there may be a requirement to redraw or redesign these patches, the patches that I referred to earlier on. Because we want to know whether the engineers are positioned properly to serve our customers. Okay. So this tool has been created to help us do that. So what we have in this particular use case, we have 9 patches, want to go to 7, either because we've launched a new product or there is an organizational, we have reorganized the way we want to run operations. We look at the current state that was green, highlighted some areas, and then the objective is to ensure that we can maximize the utilization of the engineers, minimize travel, because that is waste, of course. Make sure that we have a fair share of demand across the patches, fair share of engineers, again, across the patch, line management, and so on and so forth. And And then we run simulations. Okay. In this case, it's a GA. We look at historical data, look at what the engineers can do, the skill sets, and so on and so forth. And then after a while, we get to a point where we have those 7 geographical areas. Okay. So again, these are tools that the operational teams use to help them simulate and understand the impact of changes to the boundaries, okay, that the organizational boundaries that they have. And of course, once that is done, we do have some stats that shows us the supply demand balance. Another tool that we have developed, it's to help us, similar to the previous, but to help us optimize where we deploy spares for the engineers. Again, look at the way the organization is structured. We look at where the demand is. So if there is a specific area, in this case, we use a clustering to a specific area, we're able to highlight those areas. Okay, so let's say if you want 3 locations or 20 locations, you specify that. And then the tool, again, using historical demand and so on and so forth, will come up with those clusters in terms of where we should position these spares so as to minimize travel for the engineers. These are all models that have been built reflecting the way we want operations to run. So we do use the term model office. So whenever there is a transformation program, there is effectively the to-be states. Yeah. And these are underpinned by the models that I'm showing you here. Of course, once we have done that, you always want to know whether what has been implemented is right. So on the day the engineers go about delivering service, they have trackers, we track, telematics capabilities in their vehicles, so we know where they are at the ellipses. Okay. We expect them to be in these ellipses if they, for whatever reason, are outside of that. We want to know, is it because spares are not properly positioned and so on. So this is like closing the loop after the design phase. And then we can, one of the things we can do is to simulate or look at those constant areas that we expect activity to be. It's like a heat map. And we can simulate what actually happens on the day. Okay, so this is playing back what a journey an engineer also took on a particular day. So it is a digital model, okay, or you could say a digital twin of operations, okay, our field engineering operations in there. And then this is just highlighting some other tools that we have. So this is our scheduling tool, giving work to the engineers. Some of them work on capital build work. So jobs that span multiple days. They could be working as a team. So we need to assess if anything goes wrong. Again, we should be able to get a replacement for that and so on. What I've shown to date, so you could say phase 1 of our attempts to build a digital twin our field engineering teams. I mentioned that everything has to be business case driven. So we have helped the business achieve around 500 million savings to date. And we're able to offer fine-grained appointment slots, simply uplifting utilization, reduction in travel, reduction in CO2 emissions. And this for us, improvement in employee well-being, it's a very key, most of these are hard metrics, so you would expect that from any business case. But in terms of it, and this was way before our focus on employee well-being. Okay, a few years ago we did this work. And the reason why we saw a reduction in mental health absences, or let me put it this way, a reason why we were able to capture this data was that we had fine-grained, very detailed way to know what an absence type is. So when an engineer is off sick, we do know. Okay, it's very fine-grained. And this enabled us to report on this. So how do we scale this successfully? Done that for our field engineering teams. How do we scale this? How do we do this across the other areas in our operations? So earlier this year, we embarked on a digital transformation program with a focus of being data first, cloud first, and AI first. How do we ensure that we can provide easy access to good quality data for everyone within the business? Because that's the foundation. A key enabler for us is cloud. So we work with the hyperscalers in this space, and of course, accelerate the way we deliver value. Because as I mentioned earlier on, it's the value that we deliver to the business that counts. And they're not interested in digital twin per se. It's the outcome that they want. So for phase two, I'll touch on the operations phase two. In the network space, what we have done today, and we are looking at the maturity levels for ourselves. One of the use cases that we have successfully delivered to the business is around smart energy modeling. So I mentioned that BT consumed just under 1% of the UK's electricity. So what we have built there is a digital twin of our network, but from an energy perspective, or energy consumption perspective. So within our core access mobile network, we do know from a building, from a site, right down to the racks, the cards in our buildings, the services that run on them, the energy that is consumed. Okay, we've instrumented this and helps us to target how we compact our network. That is how we swap out old kits for new. Because some of these old kits are very energy intensive. Okay, they consume quite a lot of energy. So we have embarked on that process, and that tool is helping us with the rollout of electric vehicles across the business and so on. The next area is managing capacity in our core network. Again, tied to the first use case. So what we are looking at here is how we ensure that capacity within our core network is properly optimized. So when we are swapping out old kit for new, impact on our services and so on and so forth, it's minimized. In building design, so when we're rolling out fiber, making sure that we work with the Housing Builders Association, because they built these houses or premises. How can we make sure BIM, okay, that's a well-established standard, work with them to ensure that we can have a proper digital twin, okay, and run what-if scenarios. Knowledge management. So again, being a company like ours, we do have people who have spent all their time within the business or their careers, acquired massive knowledge in the way we operate our network. The question is, how are we able to tap into that and pass it on to the younger generations? Now we're using quite a lot of digital twins to help us do that. And of course, how do we go about modeling our exchanges? We have about 5,600 exchanges across the country underpinning our network. How do we go about making sure that whatever goes in there, it's visible to all those who need to be aware? So just to flag this, in terms of network repair, a few use cases, discovering faults. So we do have hundreds of thousands of faults. Do we know where everything is? Are they in the right state? And all those things. AI is helping us to get that straight. Blockages in that, so we do have that. Again, to lay fiber, getting it right first time. Want to make sure that we can predict blockages so that we can minimize wasted effort in there. And of course, tree. So we do have aerial, part of our network is aerial. Okay. Trees can cause damage to them. So being able to predict where we should cut trees or work with others to cut trees so that we'll have a smooth operation when it comes to our networks and so on. And then our cabinets as well. We're using some machine learning techniques to help us spot capacity in our cabinets, our green cabinets out there, so that we can add more services in there. So this is a quick demo of one of our capacity management tools. So the idea here is that we want to swap out old kit for new. There are a lot of constraints, either due to the rack size or what can go in the power and so on and so forth. So what we have done, look at ways to automate this, but also from our experience, making sure that end users can override and interact with the models themselves. So if they want to move things, they can do that themselves. Another use case that we are looking at, it's EV. So I mentioned we have around 30,000 or so vehicles in our fleet. We have an ambition to migrate them onto EV by 2030. And knowing where these vehicles are is key. Knowing where we first of all needed to, we are using our estate to help recharge these vehicles. So understanding power consumption. So it's all related. I mean, power consumption in our exchanges is key, and working with the DNOs to help uplift power in those areas. So we have built a model that enables us to determine where we need to position those charging points. And of course, once that is done, we need to understand when, who, when, and where, which vehicle can be charged and so on. So what we have an appointed system that engineers can book, check, and then book to see when they can actually use those charging facilities. This is, the EV is going to change the way we run our operations. Because we have to think about charging times and so on and so forth in there. And again, this linking this with the previous capabilities that we have built helps us have a digital model of our infrastructure, our network, and our operations. Actually, this EV use case illustrates that. So it is a network dimension. It has an impact on the way we operate our field engineering teams. And of course, the vehicles themselves are assets that we need to model. So besides some trials, and by 2030, we should have all our fleets as EVs. And what we want to do is, once we have done that, we should be in a position to release energy back into the grid. So this is where working with other digital twins come into play. So we will work with the national grid, they have a digital, whatever it is, So this is that federation of digital twin concepts come into play when we get to the stage where we have transitioned all our vehicles to EV. And of course, you could have, a Keith vehicle to grade and so on. Some of the other use cases I mentioned, the in-building design. So we are working with Galliard Homes here, and so the Housing Builders Association, using them to help us understand where we can better lay our cables and so on. The challenge we face here, it's working with legacy data. Okay. That is a key thing. Most of these drawings will be 2D and so on. How do you get them in a state where we can work with them, consume them within them, and the like? And then this is another capability that we're building for modeling our exchanges. It's taking on an interest of time. So we want to know what is in an exchange. The exchange is a key asset for our network, because everything originates and ends in an exchange. Okay, so we get into an exchange, know the services in there, know the racks. Let me just go through this properly. So again, using most of these, we have to recreate, take old diagrams in 2D and try and build on that and start looking at what is it that we have in there. I think I will be ending soon. And then this is around the knowledge management piece. So an engineer goes on site. So this is very much using HoloLens all the time. They encounter is a typical use case of using the HoloLens. But what is different here is that whilst they are on site fixing the fault, we capture that session. We capture it, make it available, catalog it, make it available for others to use when they face similar issues. Yeah. Okay, so this engineer goes through that. And then a few weeks later, another engineer encounters a similar fault. But instead of calling an expert, they draw on that video to help them fix that fault. So that it's, here we are rolling that out. We have our payphones, engineers, and so on. I mentioned work with the National Digital Twin Initiative. So we are very much aligned with that program. And what we did with them and with Anglia Water, the UK Power Network, was to build a demonstrator for COP26 to help us understand the cascading effects of extreme weather conditions. So think of it, if there is flooding, Anglia Water, which is sort of East Anglia, they they should go through something about it. UK Power Networks could affect the power that may impact the way we deliver service to our customers. Okay, so this is an attempt to try and bring together different companies, organizations from different sectors to help us build a digital twin that will serve everyone. So just a couple of slides and I'll open up for questions. How can we accelerate the uptake of digital twins? I think cost is an issue. It's very expensive to embark on a digital initiative, especially if you're an SME. And as I mentioned, business cases are funded based on outcomes. So nobody will necessarily fund the digital twin, but if you're able to express that as solving a business problem that will deliver some benefits with payback and so on and so forth, then that will get through. IP, so intellectual property, And this becomes an issue when you are working with other organizations to build digital twins, because data and models are competitive advantage, or we use them to help us have differentiation in the market. So the question is, how do you go about what can you share, what can't you share? It's an issue that needs to be addressed properly. And related to that, of course, collaboration. You can't get this done by default. It doesn't happen automatically. There has to be incentives for people to collaborate. Why should we collaborate with other companies? It has been clearly stated. So we believe that there needs to be funding from the UK government to help with this. And initiatives such as the information management framework. I was talking to David yesterday about this. It's next generation ontology and so on and so forth. The question is, how do you get that realized within companies? How can we make it easier? So all good for the government funding some of these initiatives, but how can we make it easier to embed these in organizations? And then, of course, we need policies to help protect our own security. So if you're sharing data, the guarantees around those, especially when it comes to customer data and so on and so forth. And then research challenges, digitizing legacy estate, if we can get some progress in there, will be great. So tools to help us retrofit, that will be a great one. And then I touched on, of course, a whole set of tools around middleware solutions to incorporate on board. So if we have this federation of digital twins, how do you go about coordinating those? Visualization, great work being done with mixed reality technologies, but how do we make that more user-centered? I was reading an article over the weekend. Someone was actually asking the question, why is it that organizations struggle with data initiatives? And the person was constructing this with the consumer world. So if a consumer is using Google or Yelp, they don't think, or you and I wouldn't think that we are using data products, but they are. Okay, we take it for granted. We don't even think about it. But within organizations, it's so explicit that there's a separation between what's actually happening. And then we ask for reports upon reports upon reports to illustrate. Okay, so this author was suggesting that we need to make sure that we link those data solutions with the capabilities that we are developing and not see them as separate. So you don't come up with requests for reports independent of the applications that you are using. And then, of course, data quality issues, we touched on those. How do we do this at scale? Especially if you have a brownfield estate, IT estate. How do you do this at scale? All well and good to illustrate this can be done for a particular use case. Like you're doing it for the whole operations. How do you go about doing that? So I will end here and open up for questions. Thank you.
Thank you very much. Right. Omer will be able to assist also in case we have any online questions. We're going to do that. Right. Any questions from Gilbert? Yes.
My name is Zoltan. Regarding the maintenance of
Yeah, so for us, the way that's a very good question, thanks. In terms of finance, so we have a number of approaches. Okay. So one is whenever you have an asset, let's say a power plant in our exchange. So there's a typical use case that we are working on. You have a cycle of maintenance. All the things that we discovered was that there was wasted effort. Some of them were being maintained, not looked at in terms of the maintenance cycle. That wasn't required. Okay, so we needed to use some intelligence, because if the machine hasn't failed and basically look at the health of the machine and so on and so forth, there's no need to go and service it. Yeah, that's the word I was looking for, then service it. So we need an intelligent way to be able to service these equipments. So two previous slides that I showed about the exchanges, having a model of those exchanges or those equipments within the exchange, just knowing the history, knowing the performance of those equipment enables us to intelligently plan the way we go about maintaining them. So this is all done. We do that in-house. Others, we use predictive models to detect anomalies and then respond to them beforehand as well. Yeah. And of course, yes, we store the data on the cloud, because most of these are streaming telemetry data.
Yeah, so first of all, thank you. Fantastic presentation. So I guess my question is that in a digital twin, in addition to understanding what you include in a digital twin, how do you know what to leave out? Because often the complexity of this can easily grow up. So for example, understanding what to abstract and what not to, how do you make that decision?
Very, very good point. That's why it's business case or use case driven. So the approach we have taken is that we look at a specific, we build these twins around specific use cases. But of course, when it's first engineered, we make sure that it's designed in such a way that I'm trying to think of we can evolve the capabilities with time. Okay, so a case in point, that energy digital twin. That was done. That was the first capability that we built. Then there was a need to overlay that with the electric vehicle. So the base was there, and then we evolved that. So it's like object-oriented. Yeah, so that is the approach that we are taking. Because you can't build everything in one go. The business will infund that. That's not even possible. Yeah.
Thank you. I'll ask just a couple of questions, if I may, but before I go to ASIC, and then if we have online questions as well. So back to your great example about workforce management, just a couple of questions there. In terms of predicting the demand, are you using a big data approach, or you are focusing on smaller data sets regarding that? And also, have you seen any particular types of algorithms or machine learning approaches that appear to perform better? Say, for instance, deep neural networks versus Bayesian probabilistic networks. Any kind of oversight you could share with us?
Yeah, so it is big data, lots of data. So in that space, you have telemetry data from vehicles, demand data, again, from what we capture from customers and so on. Approaches, it is mixed. Okay, we use a mixed approach. Yeah, regression for pure demand forecasting, that seems to work well. Bayesian probabilistic models, yes, as well. Neural nets, not so much in terms of the demand, but for image recognition. Okay, some of the work we've done in our cabinets, for example, we've used neural nets there. I mean, one of the reasons it's being in a position to explain why you should send an engineer to this place or that place. Okay, neural nets will be able to fix that for us. So it has to be, it should work, but then we should be able to explain.
Fantastic. Thank you very much. That's it.
Yes, my question is about this bi-directional communication or digital twin in the. We know that computer models are mostly discrete systems, whereas the hardware systems are mostly continuous systems. So how we would basically bridge the device when we try to bring these two things together? So we would have to probably produce new kind of AI models, or new kind of theory. What's your take on that?
So yeah, the way we are approaching this. So if you look at the again in the core network, take anomaly detection, for example. So we have a model, continuous, so we can spot anomaly. The challenge is how do we effect the change in the device? And of course, this is where we need to work with the device manufacturers, the APIs that are exposed to us, and so on and so forth. So that if we want to tweak some of those parameters, we can do that. And they're also coming on board. Some of the network players in this space are also developing AI capabilities to help. Yeah, so it is early days, but you're absolutely right. That is where we want to get to close that loop. So all well and good, identifying a problem, but how do you do that automatically without actually getting a human to press a button or something like that? Yeah. So
Great. John, any questions? So from online? No. Okay, probably I can close with just a final, very quick question. Very interesting presentation. Standardization. Is this the time to be talking about standards for interfaces between digital twins, or do you think it's still a little bit early for that?
I think we should. And some of the work that the National Digital Twin Initiative is looking at includes standardization. I mean, the earlier we get it right, the better. Because what we don't want is that we all go in our different ways and then have to come back. Yeah. So I don't know that it is a right time for it. Yeah.
Great. Thank you very much. Any closing question? Okay. Well, thank you very much for this excellent and very informative presentation. Thank you very much.
Pleasure.
We need to give these.
Sure. Just asking.
So, Luis, can you
Yeah, I'll just make him co-host.
present your slides?
Yeah, just 1 second. I'll make you co-host, Luis.
Oh, thank you.
Okay, go ahead.
Yeah, so just